Hello friends, so this is the another example of a static structural. So in this example we will discuss how we apply the point load and how we apply the moment in a simple supported beam. So this is our cross section 100 into 100 and this is in the modulus of elasticity is 200 gigapascal. This is similarly like a tensile yield point strength, and after the analytical method we will get a result of maximum bending stress 179 megapascal and maximum deflection that is 85 mm. So let's do the analysis and check it is matched with the analytical method, and if it is not matched, then what will be the differences. So go to the Ansys. Now just click on the static structure or drop in on the box. So after dropping inside the box, just go to the geometry and new design modular geometry. Now once this design modular open, now we make this type of a structure. So the cross section is 100 into 100 mm. So just make a cross section. So go to the XY plane and go to the sketch. So today I am going to show you one new command how we can make it easily this 100 into 100 cross section rectangle by using a grid. So if there is one method by going to the sketch and draw the rectangle, and after drawing the rectangle we need to give the dimension and constrain this rectangle. So instead of this we are going to the setting, there is the option grid. So go to the 2D or snap. So once you check, so there is a measure grading of spacing and minor step per measure. So this is the measure, just make it 100 meter. First you convert the unit from meter to millimeter. So this is 100 mm. So the minor step is 5, just convert into 1. So what will be the changes you can see here. So again go to the draw. So what the benefit we get, so you can look here, choose the rectangle. So choose the rectangle and make a rectangle here. So you can see here this single block is of 50, and this is the 50, this is the 50, this is the 50. So this is the rectangle of 100 into 100. So this is the benefit of this grade. So again go to draw and generate. So the rectangle is generated. Go to the setting, go to the grid and switch off this. So in 2D and snap. So this will be easily visible. So again go to the modeling and go to generate, then extrude, then apply. Just select this sketch and apply, and here it is asking the depth. Just see the length is here 3 to 5, that is 10 meter. So 10,000 mm. Now go for generate. Now once you generate, the beam is created. So next you have to go to the model. So before going to the model, you need to split the face to apply the point load. So how we can split the face in the Ansys? Look very carefully. So just click on this face, because you see in this figure there is a point load on point E and there is a moment at point D, and from A to C the uniform distribution load. So this you can easily use on the face, but the problem how to do how to use the point load. So look carefully, go to this face, select this face and there is one option here, new plane. Just click on the new plane, and look, there is a creation of one coordinate system. Then go to generate. So after generating, so this rectangular is created on the surface. So we need to give the point C, D, and E. That is the 3 points we need to give in between these 2 points. So go to the sketching, modify, select offset. Now click here, and after clicking, you see there is a blue line, and on that blue line just right click on that line, and there is an option of end selection. Just choose end selection. Just give the 3 points, suppose 1 point, 2nd point, and 3rd point, and to exit just right click and end. So now see here the geometry is constructed, that is the line geometry. So next what you have to do, you have to do the dimension. So go to the horizontal, select this line and select this line, again select this line, select this line, select this and this line. Now H1. So you look here, the distance is 3 meter, 2 meter, 3 meter, 2 meter. So this line is 3,000, 2,000 and 3,000. So this is automatically 2 meter. So now after doing this, go to the modeling and generate. Now if you again select this face, the entire face is selected. It means the face is not splitted yet. So how you can split these faces? So for split these faces, go to the tool, and there is option face split. Click on face split. Now it is asking us to target face. So this is our target face. So we have to split this face. So this is our target face. Just select this face and apply, and it is the tool. What is the tool geometry? Just tool geometry, and click this edge. By pressing Control, you can select all the 3 edges, and here go to apply and go for generate. Once you do the generate, now if you select the face is splitted. So this geometry is ready for giving the boundary condition. Now go for model. Now you are inside the model. So in this model we will do the analysis. First mesh this structure, go to mesh and generate mesh. So after meshing, apply some boundary condition, like go to the static structural, and you see in the figure there is a 2 sides. So support, fixed support, just choose the edge and let's zoom it. Choose the edge and choose this, and so this edge is fixed. Now we go for free support, static structural, insert, and there is the option displacement. So I have to give the displacement on this edge. Select edge, this edge, and apply. So look here, this is free in Z direction and it is constrained in Y and X direction. So just putting the value of X and Y 0 after putting, so this Z is free. Now see, at point E we have to apply a 4 kilonewton load. So apply the force, this point, go for load, force, and select this edge and apply, and the magnitude of the force is 4 kilonewton. So instead of vector we choose component, and in Y direction 4 kilonewton load is applied. Now you look here, the force is in downward direction, so this is accurate position. Now we go for load, go to the force and select this face to apply the UDL load. Apply, instead of vector go to the component and in Y direction. So what will be the load? There is a 4 kilonewton per meter, so the load is, if you convert this UDL into the point load, it will become 12 kilonewton load. So apply 12 kilonewton. Now next is the moment, that is at point D, that is 10 kilonewton per meter moment. Just again static structural load, there is a option of moment. Now select this, apply, and the magnitude here is 10 kilonewton meter. So go to the component, and now the moment is rotating along the X direction, as you see here in the X direction. So go apply the moment here, 10. Now it is clockwise direction, so convert it into a clockwise. Here the direction is anti-clockwise. Now the direction is changed, so this is like our problem. Now you see, go to the static structural. Now there is a UDL load at point D, there is at point E, there is a bending moment in clockwise direction, and the bending moment 10 kilonewton mm. So this is mm, so again go to the moment, and here 1 2 3. Now this is 10 kilonewton meter. So now it is 10 kilonewton meter moment. Now go to the structural steel. Now go for the solution to see the result. So the solution is completed. Now we apply the, now let's check the result. Go to the solution, there is an option stress, equivalent von Mises stress, and also you go for the directional deformation. Again go to solve. So after solve you just see the equivalent stress. Just now this is the fixed side and this is the free side. So just take a look in animation, so how the beam will deform. So the maximum stress we get here 109.31 megapascal, and here the maximum bending stress is 179 megapascal, and maximum deflection is 85 mm. So go to the deflection. So the maximum deflection here so we check the deformation in Y direction. Again go for solve. So the maximum deflection here 92.9296. Go to the probe. So there is a maximum deflection in the middle because it is showing the minimum because it is in negative direction. So this is the maximum deformation 92.296, and it is some dissimilar with the analytical method. So like this we can do the analysis and find the stress and directional deformation of the point load in a simple supported beam. So that's all for today. Thank you.